You want to grade first, huh?
Not really.
We'll save the grading for the end. We'll save the grading for the end of the period. Let's just the way the period is going to break down. Let's jump into inverses right now. So hold on to that. I went ahead and put an extra day in the calendar for review. So the test is not this week. The test will be next week. We're on page 405. Question: if I had a function y equals x squared, so there's y equals x squared. If I wanted the inverse of that function, what would I do?
Flip it over the line y equals x.
Yeah, we could flip it over the line y equals x. So here's the line y equals x. And so we take that and we rotate that over the line and it goes this way. And that gives us the inverse. And that's a nice graphical way of doing it, right? Well, what happens if we were to do the same thing with a sine wave? All right, so there's y equals sine of x. If we want to find the inverse, and the inverse would be, well, and actually, if we want to be consistent about the variables, the way we would do it is this. Y equals sine inverse x. What are we going to do? Same procedure. We're going to rotate it over the line y equals x. And then what do we get? Yeah, we're going to get the inverse. And what's it going to look like? This is going along the x-axis. So when we take this and rotate it up this way, what axis is it going to be going along?
Y.
It's going to be going along the y-axis. So it's going to end up looking like this. Now, here's the question. Sine of x was a function. Is sine inverse a function? No, why not?
Because you have a bunch of
Yeah. Well, what we do to test for functions is we use the vertical line test, right? And if we only hit one point, we know that we have a function. In this case, if we try using the vertical line test, I actually get an infinite number of points because this oscillates or repeats back and forth like this an infinite number of times. So this is not a function. Now, this would be a problem for your calculator if you stop and think about it for a minute. Because if there are an infinite number of possibilities for sine inverse, when you put in, well, a number like, well, you know, what is sine inverse of 0.5? It could give you an infinite number of answers. So what we have to do so that the calculator isn't confused and so we actually have a function is we have to erase everything that causes this to not be a function. So we basically go from peak to peak like this. And we say we're going to erase all of this. And now this little piece right here, that little piece actually passes the vertical line test. So it's a function. Now this is why when you put in your calculator, and we've talked about this before, if you say, what is sine inverse of a half? If we look at a unit circle, this is 30 degrees. Well, what are my values here at 30 degrees on a unit circle?
Go.
Pi over 2.
This is my x value. My x value is cosine. My y value is sine. Okay, pi over 6, that's what it is in radians. Good. So what's cosine of pi over 6? It's your unit circles. You got them right there.
3 over 2.
Thank you. And a half, right? So the y value is a half. But it's also the case over here in quadrant 2. What's my y value for this point? At 150 degrees.
Negative root 3 over 2.
Yeah, the x value goes to negative root 3 over 2. And the y value is still a half. So sine of 30 degrees is a half. Sine of 150 degrees is a half. So now here's the problem. If I use sine inverse for these, if I say, what is sine inverse of a half, what is my calculator supposed to do? Is it supposed to tell me 30 degrees or 150 degrees? How could it possibly know? Because of this, it'll always answer this. Always. If that's why on the inverse function, we have to get rid of all of these other possibilities. Because otherwise, the calculator would have no way of knowing how to give you an answer. But it also causes us a problem. What if the real answer is 150 degrees, but the calculator kicks back 30? One of the things we have to do with inverse functions is we always have to ask ourselves when we're looking at our diagram, well, what quadrant does my answer come from? Should I be getting an answer in the second quadrant? Because if it is, I'm going to have to convert 30 degrees to 150 degrees using reference angles. And we'll see that in just a minute. For the time being, do you understand why we have to cut this wave down to just this little piece?
Yeah.
Okay, in your calculators, if you use the sine inverse function, your answers will always be between, look at this, here's 0, here are your negative values, here are your positive values. Your sine values for sine inverse will always be taking right here. They'll go from positive 90 degrees to negative 90 degrees. That's terrible. You can't see that from right over here. Your values for sine inverse will always give you stuff in your calculator between negative 90 degrees and positive 90. Because if we look at the unit circle, this part here, which is also this part of the wave, I get all my y values. I get all my positive y values from the first quadrant. I get all my negative y values from the fourth quadrant. So it doesn't matter what you put in for sine inverse, assuming it's a legitimate value, your calculator will always give you a first quadrant or a fourth quadrant answer, which is okay unless your answer is supposed to be a second quadrant or a third quadrant answer. You follow me? Now let's take a look at cosine inverse. If this was sine inverse, let me erase this.